So the Arctic is a place that's changing very rapidly, and one of the things that's come up a few times throughout the semester is the context of contemporary climate change and the extent to which it affects the practices of archaeology in the north. So today what we're going to be doing is looking at this topic in a little bit more detail. So in this final section of the course, we're talking about some of the things that characterize contemporary archaeology, some of the key issues and sort of ongoing factors that structure the way that research is done in a variety of different ways. And climate change is a huge part of the way that archaeology is practiced today in the Arctic. There's a lot of urgent concern about the well-being of archaeological sites. As we're going to find out today, they're being impacted in very extreme ways on a very widespread scale. But also, it has the kind of wider context of global change has a variety of social impacts on the communities that archaeologists work with very closely across the Arctic. And so it's very important there's sort of an ongoing effort to make archaeology count in terms of some of the ongoing crises that are tied to climate change. So today we're going to talk about these issues in a little bit more detail. There's a couple of really good readings to go along with this. There's the Hollison article, gives you a very strong overview of some of the different types of processes that are affecting sites in the circumpolar north. That article has implications from Russia through Iceland and into the North American Arctic, which we've spent most of the course discussing. Then there's an article by Hans Harmsen and colleagues, which talks a little bit about some of the choices archaeologists have to make in terms of heritage management. The fact that sites are being destroyed very, very rapidly means that there are some difficult choices that archaeologists make. And that means that there has to be a lot of careful thinking into how sites can be prioritized. And then finally, there's an article that I'm the primary author on, but quite a few students in the department who you might know as well also participated in that publication. I think our Chalkmole president, Jill Taylor, is one of the authors of this article, for example, and also Nikki Phillips played an important role in the research team as well. But this documents some of the work that we'll talk a bit in a little bit more detail in this particular class in Northwest Greenland, and it's sort of a glimpse into how dramatic and rapid some of the changes can be, and their impact on archaeological sites. So the order of topics that we're going to talk about today, first we're going to talk about some of the processes at work in Northwest Greenland, as well as the wider social context. I'm then going to introduce a few of the topics for written questions for that final quiz, which will be released shortly. And then the final thing that we're going to do is that there's a special presentation from one of the graduate students in our department, Kaylee Baxter. She's doing some really interesting research involving a technique called photogrammetry, which she's using to understand some of the site changes that are taking place at a very important site that we've talked about a couple times in class called Summermiut. We saw lots of video from whales and crashing icebergs and things like that from there. And so Kaylee's going to close off the lecture. She has kind of an interesting and short presentation that goes on to the end of this, and I'll let her close the lecture as well. So there will be some questions that sort of kind of a general topic of information that you should look for and think about when you're preparing for the quiz from her lecture as well. So in order to understand how climate change factors into kind of contemporary archaeological practices in the Arctic, I'm going to focus primarily on Northwest Greenland as an example, mostly because it's something that I know well, but also have a lot of material that I can kind of show you to illustrate some of the points. And there's, as I said, there's this sort of both physical and social element to how climate change impacts the character of research in the Arctic. And so in order to do this, I'm going to talk about this in three sections. So first of all, I'm going to talk about how climate change impacts the local Inuit community, and what some of their kind of community-based responses to some of the changes taking place are some of those responses that are underway and how archaeology can fit into them. And this is tied to something called the Picula-Sorsuaq Commission, which I'll discuss in a little bit more detail shortly. The second point is I'll talk about some of the physical processes that are impacting sites in this region. They're very similar to ones that you see across the Arctic. So we'll look at a few illustrations and understand how some of these work and also their extent. And then finally, I'm going to talk briefly about how I think this question of prioritization, about choosing how to direct archaeological conservation efforts, deciding which sites need to have work done on them before they're destroyed, and why they should be prioritized over others. I'm going to talk a little bit about how I think that's also going to be an important factor in shaping the future of archaeology in the Arctic. Now, just as a very general overview of some of the changes taking place in the Arctic, this is really just scratching the surface. There are a lot of great resources out there that summarize a variety of different processes that converge on the Arctic. But basically, you probably already have an intuitive sense that the Arctic is one of the places where global changes are manifest most quickly. So in terms of the contemporary context of global climate change, it's the Arctic where that's being felt most immediately in terms of the present. So as a whole, the Arctic has warmed more than twice as fast as the global average since the 1980s. And there's a variety of related consequences to this that have impact in different local manifestations across the North. There are dramatic changes taking place in terms of the seasons and their timings and some of the events that take place during those transitions. There are some very fundamental environmental changes. For example, changes in the sort of formation of sea ice, which, as we know, is crucial to Arctic ecologies. There's a variety of shifts in the relationships between species and their environments that are underway as well. There are invader species. There are species that are struggling to keep up with some of the changes and being endangered as a process of climate change. And there are other species that are doing just fine too, that are thriving and taking over new niches too. So it's a place where there's a lot of dramatic changes in process. In addition to this, there's a lot of attention on the Arctic. So there's a question of things like Arctic seaways opening up, new types of resources that can be accessed. The Arctic was traditionally a very inaccessible and logistically difficult place to reach. That's changing very rapidly, so there's new opportunities for things like climate change tourism and a variety of other sorts of developments which have impact in the North and impact on the communities that live there. So we'll talk a little bit more about each of these in detail, but within those wider changes taking place in the Arctic, there are direct effects on archaeological sites. There's changes in coastal erosion. There's changes to the status of permafrost deposits, which, as we've seen, are linked to remarkable preservation in a variety of different places. There's changes to mass movement, which is things like landslides and other related processes where there is kind of movement of different types of clasts. And then fourth, there's also increased reasons for people going into the Arctic, tourism being another one, other types of development too, and that often has impact on archaeological sites as well, something that Kaylee will talk a fair bit about in her presentation. So just as sort of a quick reminder about the local ecology of Northwest Greenland, where we'll be talking about today, it's a landscape that's built around the most important feature there, which is the Picula-Sorsuaq polynya. It's the largest polynya in the world, and it's held together by a variety of converging complex factors that basically hold it together as this unique microenvironment that has this rich local ecology and all kinds of opportunities for both human communities and animal communities alike. It's a rich ecology, but also a precarious one, and so when there's small changes in some of those factors that hold the polynya together, for example, the timing of the formation of the ice bridge, which is where the open water is basically kept open by factors like currents and as well as the winds that are continually breaking up ice along the edge. But any kind of small change in those factors results in all kinds of cascading consequences for the kind of seasonality of some of the opportunities that are there. It has impact on animal populations and their behaviors. In general, the sort of instability in this environment is tied to these elongated warm seasons. So kind of paradoxically, in a way, the stability of the open water system there is actually much more stable when temperatures are colder, because you get that formation of the ice bridge that's quite solid and stable, and that allows the polynya to form each year. As it starts to get warmer, or as you have these elongated seasons, that ice bridge becomes more unstable. Its timing is more erratic. Its positionality is more erratic. And as a result, you have these kind of follow-on consequences which affect all of the communities that live in the polynya. Those elongated warm seasons also mean that you have a longer season where there can be things like precipitation and storms, and that also is having a significant impact on the landscape, as we'll see in a moment. So those types of changes underway have significant impact on daily life for the Inuit communities who live in Northwest Greenland. It's their traditional territory and an area where their ancestors have been living since that Thule migration event, and have sort of had this local trajectory of development and stewardship, managing different animal relationships in the polynya. In the present, they're still very much dependent on traditional hunting. It's sort of hybridized with some modern technologies and traditional technologies, and sort of practiced through long-standing techniques for navigation and managing species, things like that. But the community is 85% dependent on food that comes from hunting. So families do still very much depend directly on things that are coming from their environment. And so they're very much impacted by things like erratic animal behaviors and population health. They're certainly directly impacted by things like contaminants and seasons where certain animals don't show up when they normally would. A lot of their traditional hunting techniques, in particular in the springtime when there's a lot of hunting at the ice edge, a lot of those are they don't really work anymore, or hunters have less confidence in them because there's a lot of instability in how those environments are changing. So it's a little less predictable how the ice is going to break up in the spring, and what sort of cues you have to be attuned to in order to know when there's danger in that environment. That winter season, which is really productive for the communities, really an important hunting season, is dramatically reduced. And along with that important ice edge environment that allows access into the polynya. This means that there's a lot more long distance travel, which requires more costly techniques, fuel to get boats into new locations, things like that. And then there's all kinds of other things going on in the background too, things like landslides and impact of receding shorelines that are impacting the landscapes and communities where people live and hunt and visit during their annual cycle. Because there's a lot more instability, this has a huge social impact on the community as well. There's increasing reliance on wage economy. And what that means is that a lot of families are having to encourage their children to study outside of the community. They typically have to go to Nook to do any kind of post-secondary training or apprenticeships, things like that. And so there's a sort of generational crisis where there's difficulty in sort of building that generation of hunters who are supporting the community in daily life. So there's a variety of things that converge and impact the community, and we can break these into both direct and indirect impacts. So the direct impacts are those related to physical changes in the environment. So those disruptions to hunting life, the impact on food security, all those sort of economic insecurities that are directly tied to that, in terms of having to complement hunting techniques with wage labor, things like that. Also, all those dangers and family crises built around, kind of this tension between ensuring that there's education, but not losing people from the community too as they go south to study. All of those changes, both direct and indirect, are very well outlined in a recent project that was organized by the Inuit Circumpolar Commission. This is a pan-Arctic organization that looks at, it does a variety of things, but one of the things that it does is it advocates for communities that don't often have great representation in different scales of governance. And ICC, the Inuit Circumpolar Commission, created a special commission on Pikilissosoak itself to kind of understand the health and the impact of climate change for the communities there, and also to think about their future and what sort of agencies they can have in directing their own kind of approaches to dealing with climate change. And those are all summarized very nicely in something called the Pikilissosoak Commission report. And I've decided to make this available on D2L because a few of you throughout the course have had some interesting questions about kind of how contemporary communities are kind of living with things like some of the dramatic changes that take place, and also have asked some interesting questions about how archaeology fits into that. So that's available on D2L. It's not a required reading, but if you are really interested in it, you can use it for one of your annotations if you'd like to do that. So the indirect impacts of climate change are also just as important in daily life. These are things that are kind of related to more the sort of political dimensions of global attention on the Arctic that is tied to this sort of increasing concern for the North and climate change in general. First of all, the world for the Inuit is controlled by a variety of different scales of governance that have impact on them. And so, for example, there's a variety of different bioconservation regulations that are imposed by, Canada, Greenland, and the EU that impact daily life, that impact the types of decisions that hunters can make and how they use their landscape. There's things like hunting quotas, species bans, a variety of other rules. And so even though there's this kind of widespread environmental challenge underway, even before families step out the door to kind of engage in the environment and practice traditional hunting, practices around that support their subsistence and livelihood. There's all these sort of limitations in terms of how they use the environment, and there's a lot of discussion in the community now too about how some of these quite a lot of these regulations can have unexpected and detrimental consequences for environmental management. And even though they're often intended to protect species, they're often not that well thought out in terms of what the kind of impact on and ruptures to longstanding management practices are. So one really good example is the ban on seal products by the EU. So you can't sell any seal related products in the EU. So this was a massive economic catastrophe for local communities because they hunt those species anyways, and species which aren't actually under threat at the moment. In fact, some of them are thriving in northwest Greenland, but they hunt them anyways and aren't able to sell some of the secondary products to support and kind of boost their livelihood as well. Another thing that impacts a fair bit is ecotourism. So there are, with increasing frequency, there are cruise ships that arrive in the area and suddenly flood the community with people who are interested in what's happening. And then another indirect impact, the one that I think archaeologists have to think very carefully about, is something I'd maybe call science fatigue. In a place like Qaanaaq in northwest Greenland, every single summer there's a flood of scientists involved in different research projects, whether they're coring glaciers or taking samples, looking at seawater or doing other types of things like that. A lot of that has a direct impact on the community. They're not always consulted in the different types of research that take place, and also it can have a lot of sort of indirect consequences to them too. So there are, for example, a lot of kind of conflicts and tensions around some of the hunting regulations that are imposed on the community without direct consultation with them too. So there's a few particular species that bird biologists in the area have been quite proactive about influencing legislations that prevent the local community from hunting those species, even though they're migratory birds and travel huge distances. They're sort of, being sort of, I guess, blamed in some way for the status of those populations, and there's not always agreement between hunting communities and those scientists about the status of those populations or the best ways to protect them. And so there is a sort of fatigue that can come from having that much kind of direct attention placed on some of these very small communities. In Qaanaaq, there's only 480 people that live there. But there's a kind of a longer and deeper history too of regulation at play here. In that area in northwest Greenland, one of the things that impacts everything is that the world is bisected by the modern border between Canada and Greenland, and there's a long history as to how that came to be and how that impacted the local communities who were mostly pushed into the Greenlandic side through a variety of factors, and our Greenlandic citizens. They can't use the whole of what is their traditional territory, which does span into Ellesmere Island, and so as a result, they're not able to use the Pelini as an integrated whole. They're also not able to make management decisions that are based on the kind of full integration of how different species relate to each other. So, for example, there's limitations on when you might intercept something like the migration of narwhals, and the seasonality of when hunters are able to access them as a result. So in that Pickula Commission, it's made up of representatives from both Greenlandic and Canadian Inuit communities. It was established through a variety of different consultation processes, and the goal was to make these recommendations. And out of that, there's a couple of key concerns and recommendations that I think are very, very important for archaeologists working in the area to consider. The first is that there's a need for locally controlled regulatory frameworks that are built from existing community structures. So there's long-standing decision processes for how the community hunts different animals, and the community is very concerned about population health because they depend on those animals. And there are long-standing structures for how they decide and manage some of those decisions, and how to sort of act as a community in a way that benefits the health of certain animal populations. The second point is the need for free movement and use between the Canadian and Greenlandic sides of the polynya, which is the second key recommendation there. What's interesting behind these that I think archaeologists can think about and consider how it might structure their work and objectives, and also prioritizations in terms of how to distribute conservation efforts between certain sites, is that these recommendations are things that the community is working towards. They're sort of self-driven goals that are structuring what the community is thinking about and what their efforts to relate to some of the changes there. And so in the work that I do and the team that I work with, this is sort of a big focus in the project is to think about how archaeology can fit into and contribute to some of the contemporary dilemmas at work, and some of those efforts that are outlined in the Piculus-Ossuac Commission. So our project began in 2017 and started with 2 years of primarily community interviews and research presentations, where we worked with local community members to try and co-engineer research objectives to an archaeology project that kind of gives the community some agency in choosing what the research agenda is and what the key questions will be. And so as a part of this work, we did a lot of visiting sites with elders and hunters to perform some of the impact assessments. So in some of these photos here, you can see my research partners. Paulina Knudsen in the photo on the left there is interviewing 2 elders. And Pivingwak Merk, a few of you might have seen him actually when he came to Nautaka's class a couple years ago to do a presentation and reading on some of his work. But he's a student at the University of Greenland who does a lot of community interview work and writing about the project. But one of the funnest parts of the research is traveling to sites that the community identifies as being important, and places that they're quite concerned about in terms of some of the changes that are happening at those sites. So they can be places where there are important family events that occurred, certain historical events. They can be places that are located in close proximity to key animal migrations or other sorts of ecological factors in the environment. But they're sites that we go to and document primarily because they've been identified as being, places of concern for the community and by the community themselves. So in a traditional archaeological project, you might have kind of a survey strategy that's structured around something more like a blind sampling strategy. So you're thinking more about how to kind of understand what's happening in the landscape as a whole. Here we've been focused mostly on places that are already flagged as being important and critical to preservation in terms of some of the ongoing crises. So one of the questions that sort of was always in my mind at the start of the project, as you start to learn about some of the changes that are taking place in the Arctic and the many different ways that they impact daily life for communities like the Inuit, even though I'm quite passionate about archaeology, obviously, and think that it's an important study. One of the things I always thought about in the background is why would with all these other things going on, why would the community be concerned about archaeology in particular? And one of the things that surprised me right away is how high on kind of the list of things that the community is concerned about, or that how high archaeological sites are in terms of their concerns for things that are happening in the environment. And I think part of it is that these sites are places where there's a lot of history anchored to those, and a lot of kind of understandings of the environment, and even in places that are kind of detached from oral history. So, for example, those earlier Paleo-Inuit sites, which are located in the area, there's no kind of direct stories about events and things that happen in those places, but there is kind of an understanding of their positionality in the landscape and their importance in terms of things like animal movements as well. And so one of the reasons why I think that they are such a high priority is that they're a part of how some of the changes are perceived. So, for example, it's often in reference to archaeological sites that observations of change are made. So a good example that I can think of is a site called Ulasut, which used to be a very famous walrus hunting site. And indeed, when you go there, there's lots of walrus bones scattered all over the surface. But because of the way that the ice edge has been forming and changing, walrus go nowhere near that area in the present, and so the site itself kind of becomes a reference for the scale of changes in terms of the deep history of the environment. The second factor is that I think as the community is working towards these efforts at self-regulation and kind of autonomy over environmental governance, there's an interest in anchoring some of those efforts in deep history, and so there's certainly an interest in what archaeology can offer for demonstrating things like these long-standing stewardship frameworks as to how the community does sort of manage and work with some of the environmental changes that have taken place in the area through time, which, as you'll probably know from your experience in archaeology, you can do through things like zooarchaeology. And so, in terms of this question, is there room for collaboration? There is quite a lot, and I think there's, in terms of the community that we work with the Inuit, they're very interested in building a framework for prioritization and kind of co-developing specific research questions that can come from future archaeological work. However, this all comes at a point in time where there are very dramatic changes taking place that do impact the status of those sites. And indeed, there are widespread archaeological destructions that are taking place as a direct result of climate change. And there's a few things that complicate this and make this even more difficult to sort of work with and prioritize efforts and respond to that are specific to the Arctic. The first is that there are vast areas in the Arctic that don't have prior systematic survey. There may be some knowledge of a few sites in that area, but there's quite a lot out there that has never really been systematically surveyed, and there are certainly very important archaeological sites in those areas that have not quite been assessed yet, at the same time as those sites in those areas may be under threat and being lost. It can be really hard even to go up and look at places that have had previous work just because of the logistical expenses of working in the Arctic. So there's automatically limitations on the extent of work that can be done and its character too. But certainly in the area that we're working in northwest Greenland, in proximity to these communities of Qaanaaq and Sjoapluk, there is extensive damage to sites. And in the kind of site visits and structured survey work that we've done, we've certainly identify a lot of significant threats that are taking place, that are having impact on archaeological landscapes across the region. The three big ones that are impacting sites across the Arctic too are first of all coastal erosion, melting permafrost, and mass movement. And I'm going to talk a little bit about each of these separately, and then I'll talk about the kind of understanding how extensive their impact is. So the first one is coastal erosion. So most Arctic communities are maritime, hunting subsistence communities, and indeed, as a result, a lot of the archaeological sites that are tied to those lifeways are in very, very close proximity to the shoreline. You want quick access, You want all that kind of maritime hunting equipment on in close proximity. But those coastlines where a lot of those sites are located are undergoing significant changes, and this is mostly tied to the changes in seasonality. Because there's a lot less ice as the warm seasons get elongated, it means that coastlines are exposed to things like storms and various types of weather and wave action that is related to that for much longer periods of time, which means that the kind of regular sort of erosion that happens in those environments is accelerated. So places that were long protected by the development of landfast ice are no longer protected in that way, and so this sort of increasing frequency of storms does have a very kind of quick effect. Because there's a lot more production of things like large icebergs that break off from the inland ice when it goes down these long fjords. It means that there's a lot more icebergs in the area, and when those flip, they also create small tsunamis, things like that. You would, if you watch the tsunami video from earlier in the class, you'll have a sense of what the impact could be on archaeological sites in close proximity to that. And then the final factor too is that as the ice sheets in Greenland are melting, the global sea level is rising too, and even a few centimeters can have a significant impact in terms of how much of the shoreline is being impacted by things like storm surges. So a couple of quick images to show you what some of this looks like. We'll come back to this specific one here a couple times because there's a few processes that you can identify here. But here, the survey team is looking at basically a shoreline that's cutting into house features. So you can see these depressions here. Those are Thule period houses that would have been occupied several centuries ago, and what's happening is that they're slowly being kind of basically eaten by the coastline there, and all along that beach there are artifacts that are spilling out out from each of those house features. Another quick example, this site is called Kangak. It's close to the community of Sirapluk. You can see all these old beach ridges that are sort of being eroded into very quickly here as the shoreline retreats. You can zoom in a little bit here and again see some house features here that are under threat. We used historical images for this particular site to try and understand how fast that coastline is receding, and it's pretty dramatic. So there's at least sort of on average 8 meters a year of these beaches that are being taken away. So these house features that you can see here are already gone in this instance. The next important one is melting permafrost. So even in sites that are not yet kind of in a situation where the coastal erosion is impacting them, they are having kind of their internal structure impacted as well. We talked a little bit earlier in the course about sites like Kekratassuk and Kaya in West Greenland, where you have this remarkable preservation of organic materials. As the permafrost melts, there's a variety of different follow-on processes that have impact on archaeological sites. The first is that those layers that have great preservation and kind of organic materials preserved in them, as those melt, there's kind of new opportunities for organic materials to be degraded, and that can happen very, very quickly for some of the fragile things like skin clothing and stitchwork, things like that. But as the permafrost melts, it also opens up a variety of different types of small localized slides and new erosional channels that can remove materials very quickly. So in the images here we have, this is a midden deposit that's starting to kind of basically fall away in chunks as it melts out. So all of those bits of bone and artifacts that are in there, there was actually kind of nice pieces of sinew knots and baleen cordage in this area as well. All of those things are being lost at a very rapid pace. And then in the image on the right here, there's a house feature in the foreground, and then Pvingoak and Pia, two students from the University of Greenland, are documenting this is what's called an active layer detachment. So it's a type of slide when permafrost melts and allows a little bit more absorption of water when there's things like heavy rainfalls. So there's a variety of things happening. The active layers are getting deeper. They can absorb more water, which allows for that kind of slippage. But there's also new things like bacteria and fungi waking up inside of these things as they warm up, and those sort of increase the degradation of organic materials, but also starts to heat up the site from the inside. And so you can have very significant changes happening quite quickly. So all that incredible preservation that characterizes some of these sites in the Arctic is under threat. So just to give you, this is NDVI image. So basically it's using infrared to highlight things that are green associated with vegetation. So what we're looking at here, you can see along the coastline, there's a really dark red area, and that's actually an archaeological site. So this image gives you a sense of how rare vegetation is in this landscape and how it is sort of clustered around archaeological sites. And indeed, it's around those areas where you have that formation of permafrost areas in this, or permafrost deposits in this particular landscape. And so as those, basically as those permafrost deposits are melting out, so too are the archaeological sites associated with them. And going back to the earlier image here, you can see there's sort of a melt channel where a lot of the kind of water that's being taken on within the active layer of the permafrost is sort of giving way and opening up new channels and cutting into some of the archaeological features there as well. So the final process, and one that's fairly new in terms of archaeological worries, is mass movement. So one of the mass movement, basically, it's also sometimes called mass wasting. It consists of downslope movement of sediment. So you can think of it as things like landslides, mud flows, soil creep, a variety of other kind of secondary deposition processes as well. In this area around Qaanaaq, the terrain is very, very steep. The surface geology is characterized by fairly soft sandstones and a variety of similar types of stone. And there's kind of, for most of the Holocene, some of these slopes have been fairly stable. They have kind of limited warm seasons and limited. A lot of the snowfall on them disappears through things like sublimation, so you don't get as much water carrying and transporting material. But over the last 10 years, one of the things that's changed dramatically in this area is the amount of precipitation that falls as rainfall. It used to be predominantly snow, but because you have these longer or elongated warm seasons, it means that there's a higher chance for rainfall. And when rain falls in an environment like this, it can cause all kinds of accelerations to those mass movement processes. And so as a result, there have been some very, very dramatic changes. And most of the fjords, you can see these extensive scars, which are basically the result of something called a debris flow that seem to be very recent in terms of their most of their situations. So a lot of these fjord systems, there's kind of historical satellite imagery you can look at, as well as photos from hunters that kind of demonstrate how recent some of these debris flows are. And those debris flows certainly impact archaeological sites in a number of different ways. So you can get a sense of one here. It's on a slope that seems to have been fairly stable through most of the Holocene, but this particular debris flow started in 2016. You can see it cuts into any kind of deposit, and also can bury archaeological features through all that debris along their edges. And then a lot of that material that's loosened up by these debris flows is then transported in streams through alluvial action, and then deposited in a feature called an alluvial fan, which is basically a fan of transported materials that are deposited. And alluvial fans are very common features that where there are archaeological sites located. So they kind of produce these points of land that give you a good view shed on both sides of any given fjord, and of course they have access to fresh water from the feeder streams, and so they tend to be locations where there's a density of archaeological sites. But because there's all those debris flows happening, and then there's this rapid transport and deposition through kind of the higher rainfall and the increased volume of streams, there is significant damage to sites that are located in these features. So in the examples here, these are actually house features that you can see have been damaged in satellite images here. So you can just in the images on the left, you can just make out some of the house features in the lower left section there in the images from July 2011. There was an anomalous series of rainfall events in 2016 and 2017 in this particular area that resulted in the activation of that alluvial fan there. And you can see in the image how many of those sites were damaged and also completely destroyed as well. So the orange arrows are house features that remain, that we were able to survey and document what's left there. Most of them are significantly damaged, and then the red arrows are places where house features were removed entirely. So a very sudden change in terms of the history and development of that site. There also used to be early Paleoinuit sites on this particular alluvial fan. So ones from that period that we associate with, say, Independence 1 or Sakak, so going back about 4,400 years. And so the presence of those features on this alluvial fan, which have now been removed by its reactivation, is sort of an indication of the scale of this change relative to the Holocene. So these images here give you a closer look as to kind of the dramatic scale of some of these changes. There are a variety of aerial photos that have been projected onto the elevation model for the landscape, and you can see basically between the 2011 and 2017 images, there's all of this new scarring along all the kind of major slopes there that is fairly widespread and represents a significant change in the sort of material that's moved there. So as a part of this work in trying to understand how extensive these kind of processes are, basically as a part of the work, we researched, we surveyed a couple of key areas in high detail to understand how many features are represented in sites like this, as well as how extensive these processes are in terms of the damage that they're causing. So in the image on the left here, you can see sort of a variety of the different features that form there. There's debris flows scarring the slopes there. There's the alluvial fans, which are reactivated and being expanded. There's also a variety of different slides tied to permafrost, and this particular permafrost deposit is because the sites are sitting below a colony of birds that nest there. And it's because those birds are there that people have been returning to this site for many thousands of years. And one of the consequences of that is that there's a huge density of sites and features all along this landscape. And so The archaeological landscape, which is about 30 meters above sea level here, you can sort of see it represented by this yellow band there. There's just hundreds and hundreds of features that are in that area that are being impacted by some of these changes. So if you read that article on the hydrological instability, which means changes in the rainfall and resulting mass movement in this area, you can see that there's significant consequences for archaeological features. So up to 44% of what we can call the archaeological landscape was affected in a very, very short period of time. And based on kind of the survey and projections that we did, we estimate that probably about 374 archaeological features were lost between 2011 and 2017 as a result of these high rainfall events that took place there. So that's just in an 11-kilometer stretch of coastline, and one that is not necessarily any different than kind of what's happening in the wider landscape. So it sort of gives a glimpse into the just the extent of how damaging some of these processes are, and the types of how quickly some of those changes are taking place. So one of the ways that we can keep up with this and kind of assess the vulnerability of these sites, given that it's impossible to survey all of these areas just because of the logistical challenges, is through GIS and remote sensing. So that is using satellite imagery to look carefully at some of the historical changes that are taking place and identify, that can be used to basically identify some of the areas that are under the most immediate threat. So in terms of, if you're interested in going forward in Arctic archaeology and, kind of doing a bit more or finding some opportunities to do some RA work, research assistantship, things like that, taking opportunity to take some GIS classes or remote sensing is a really, really good idea that opens up a lot of opportunity for you as a student. They're great skills that any archaeologist can use, but they're becoming particularly important in the Arctic in terms of just sort of appraising and keeping up with some of the changes that are taking place in the landscape. So in terms of the actual physical impact to archaeological sites, that certainly is one way of assessing and knowing about those types of things. But it raises kind of the question of prioritization, so which I think is going to have a very important part in the future development of Arctic archaeology. One thing that you can get a sense of from those images is that even as we talk about some of the processes that are affecting archaeological sites, they're being destroyed at a rapid rate, and they're being destroyed at a rate that is certainly beyond the capacity of both archaeologists and communities to step in and do something about every single site, and that means that not all of them can be saved. Which means that there has to be some prioritization of efforts. So any type of archaeological work that happens right now, there's a lot of kind of thought, I think, put into how important it is and what it contributes to, and what sort of questions are the big questions that archaeologists need to answer while there's as much opportunity to do that as possible. Certainly, one of the most important things is to try and anchor any sort of research in some of the ongoing community challenges and responses. So, where you have these recommendations from something like the Picula Sorcerer Commission that are calling for certain things like understanding long-term regulatory frameworks and calling for justification of free movement across borders so that the area can be used as an integrated whole. All of these things are things that archaeologists can contribute to in terms of providing information about the deep history about those things. On its own, archaeology can't be the only basis for that sort of a development and future in terms of autonomous regulation of those areas, but it can certainly provide a lot of important materials that can be taken up in those efforts. And so I think, kind of thinking very carefully about what archaeological work needs to be done in terms of its potential to contribute to ongoing crises in the Arctic is really sort of the future and direction of some of the discussion that's taking place in Arctic archaeology. Throughout this course, we've sort of looked at the outline of what archaeologists know, the dates and periods and changes in lifeways and sort of the general evolution of the story of these relationships between communities and Arctic environments through time. I think for the most part in those previous periods, the focus has been in filling in the gaps, right? And trying to kind of get a bigger picture of what the shape of the past was like in the Arctic. But I think going forward, probably there'll be a lot more emphasis on thinking carefully about how those accounts of the past are assembled in terms of their impact in this ongoing pressure and focus on the Arctic as a whole. So that brings us to the last section of what I'll be talking about today, which is just introducing some of the questions from this material, or topics for questions from this material on climate change that could be on the quiz. The first is to really, as you're studying and preparing for that final quiz, there'll be 3 written questions, as I mentioned before. In terms of the climate change-based questions, 3 topics to think about are this. So first of all, you want to make sure that you know and understand those physical processes affecting archaeological landscapes in the Arctic. So the melting permafrost, the coastal erosion, the mass movement, and understand, in particular, how it changes archaeological sites and what the risks are and how extensive some of those destructions can be. The second one is to think about some of these criteria for prioritization of archaeological conservation efforts. So linking, that question of choosing between different sites, choosing how to kind of use funds for archaeology and thinking about what sort of work needs to come to the forefront of what archaeologists are doing in the Arctic as a community. And then finally, the last question is tied to the presentation that Kaylee will start in a second here, which is using new technologies. So she's going to talk a little bit about photogrammetry and how it can be used to document sites and assess changes that are related to erosion and permafrost thaw. So I'll switch now to Kaylee's presentation, and I'll let her finish the lecture today as well.
Hello everybody, my name is Kaylee Baxter and I am one of Professor Walls's archaeology graduate students. I'm in the first year of my master's degree studying Arctic archaeology with a focus on the impact of climate change on the archaeological landscapes of Northwest Greenland. Today I will be presenting a guest lecture about photogrammetry and 3D modeling, which is a technological method of archaeological investigation, and it's a method that's especially useful in the Arctic. Specifically, we'll be exploring photogrammetry as a means of mitigating climate change-related destruction of archaeological sites in the Arctic. Before I continue, I thought it would be helpful to quickly go over an agenda so you'll know what we will be covering in this presentation. First, we'll be looking at the impacts of climate change processes on archaeological sites in the Arctic. From there, I'll introduce photogrammetry and 3D modeling as a method and tool to mitigate these impacts. Next, we'll discuss the benefits of 3D modeling Arctic sites. Then we'll ground the discussion in the real-world example of the site of Surmurmiet in West Greenland, which I'm currently working on creating a 3D model for. Lastly, we'll consider 3D modeling and photogrammetry as not only a useful method for digitally preserving Arctic sites, but also as a method that really is going to be the future of archaeological investigation in the Arctic. The impact of climate change processes on Arctic archaeology occurs primarily through two things: erosion and permafrost thaw. These two processes have a physical impact on archaeological sites because they cause rapid artifact loss and feature destruction. Erosion and permafrost also negatively impact archaeological knowledge and the archaeological record. The physical loss of site artifacts and features consequently results in a loss of information, and our archaeological interpretations of that site are limited or even fully inhibited depending on the amount of destruction. Evidently, these climate change processes have a big impact on Arctic archaeology. To mitigate these impacts, archaeologists can implement photogrammetry and 3D modeling as a way of digitally preserving sites that are physically deteriorating. So, what is photogrammetry? Photogrammetry is a scientific method of measuring topography, a landscape, using photographs. Broadly speaking, it's used to create a single photographic image that's as accurate as possible, and this is typically done by merging or stitching together multiple photos. With modern technology, the term photogrammetry also refers to developing 3D models from still photographs. When we say photogrammetry, this is what we're talking about for the sake of this presentation. Photogrammetry is applied to Arctic archaeology through aerial and satellite photographs, which archaeologists can then develop realistic, high-resolution, and even geo-referenced 3D models of sites and site features. If a 3D model is geo-referenced, that means it's associated with real-world coordinates and can be incorporated into different types of GIS analysis. Now that we've covered what photogrammetry is and why it's used as a tool for site preservation in the Arctic, we will discuss the major benefits of 3D modeling. First, 3D modeling presents interesting archival opportunities. By digitally reconstructing an archaeological site using photos taken in a given year, archaeologists can create a digital record of a site, so to say. If additional models of the same site are created using photos taken in a different year, we can create a comparative library, so to say, of the site over time and compare the site preservation during different years. 3D modeling is also a non-destructive form of documenting a site. Because 3D modeling does not require excavation, we can digitally reconstruct a site's surface without causing any physical impact. It is also an efficient and cost-effective method compared to extensive field survey and excavation. 3D models also allow for increased access and perspective. Because these digital models can be shared through the internet, local and non-local Indigenous community members and elders, external and internal and international researchers can all access the digital copy of this site and help inform archaeological interpretations without having to physically visit the site. 3D modeling is also broadly applicable as a method across the Arctic. For example, methods used to 3D model a site in Greenland can also be used to 3D model a site in the Canadian Arctic. Ultimately, 3D modeling opens up new possibilities and enhances existing possibilities of site, feature, and artifact analysis. This means we can build multi-perspective and more comprehensive archaeological interpretations of sites and their context. Now that we've covered the benefits of applying photogrammetry to Arctic sites, we will look at a real-world example of digitally reconstructing an archaeological site. For this, we'll use the site of Surmurmiat in West Greenland. I know that Surmurmiat has come up in previous lectures, so I'll just give a brief context for the site before discussing the 3D modeling process. Greenland. It's in the Disko Bay area, which is a very archaeologically productive region in Greenland. Surmurmiat is a significant multi-component site with 3 distinct cultural occupations. Excavation in the 1950s uncovered and determined a sequence of Sakak, early Dorset, and Thule cultural occupations. The site includes house and dwelling structures, middens, and various artifacts. Here are 2 more images to provide a geographic context of the site. In the image on the left, you can see the town of Ilulissat, and on the right-hand side of the photo, we have the Ilulissat Fjord. Surmurmiat is to the bottom right of Ilulissat and to the left of the Ilulissat Fjord, located in the small bay-like area. The picture on the right is a close-up view of the site. The physical geography of Surmurmiat makes it especially vulnerable to the 2 primary processes of climate change destruction in the Arctic, erosion and permafrost thaw. Erosion poses an increased threat to site preservation because Surmurmiat is a coastal site. As the coast continues to erode, artifacts are quite literally spilling out onto the beach and features are being destroyed. Semermiat also faces a third climate change-related threat in the form of climate change tourism. Semermiat is located in a UNESCO World Heritage Zone, and its close proximity to the Ilulissat Fjord and glacier makes it a prime tourism destination. The area surrounding Semermiat is famous for dynamic ice activity and animal life, especially whales, and this generates a large tourism industry in Ilulissat. As ice breaks away from the glacier and floats down the Ilulissat Fjord, large concentrations of icebergs can gather in Disco Bay and in the fjord. In the photo here, you can see the Bay of Icebergs from Semermiat, with a group of tourists standing on the pedestrian path. Increased tourism to the area has also resulted in increased foot traffic over the site surface. Prior to there being a pedestrian path, people would walk over site features and unintentionally damage the surface. So now that we have established why Semermiat is a prime site for digital preservation and 3D modeling, we can discuss the process of creating a 3D model of an archaeological site. Here, the process is simplified and broken down into 3 main steps. First, you need to take photos. Aerial photos work best, and this is typically done by using a drone or acquiring satellite images. Once you have your photos of your site, you upload them into a 3D modeling software. For my research, I use a software program called Agisoft. Once your photos are uploaded and aligned in the program, you set parameters for the model and generate it. The generation process of the model and the rendering process takes the most time. Depending on how high the resolution of the model is going to be, the time can vary greatly. The higher the resolution, the longer the processing will take. This is a screenshot of the completed 3D model of Semermiat in the Agisoft software. This model was created by stitching together over 300 photographs. This particular version of the model was run on low-medium settings, and even the detail and resolution here is quite impressive. Agisoft also allows you to run different types of analyses within the program. For instance, here we can change it from a textured color to a solid color. By changing the color, you can pick up different changes in areas of interest on the surface level of the site that otherwise you wouldn't be able to see. Once we've built these digital models of archaeological sites, there are multiple things we can do with them. Change detection and archival purposes go hand in hand. By developing multiple models of the same site using photographs of different years, we both create a digital archive of the site and have the opportunity to assess changes happening to the site over time. For example, we can measure the rate of coastal erosion happening at Semermiat over a number of years. 3D models are also excellent tools for knowledge mobilization and information dissemination because they can be shared with researchers and interested people who may not be able to otherwise physically visit the site, but who can still contribute new perspectives and interpretations of the site and its history. Finally, the primary goal for these 3D models and digital reconstructions of archaeological sites is to help build prioritization frameworks for site preservation by local communities. It's an unfortunate reality that Arctic sites are disproportionately affected by climate change processes. As a consequence, some sites will deteriorate and disappear before we're able to excavate and fully document them. Projects like the 3D modeling of sites like Semermiat will help us assess which sites are facing the biggest impact from climate change related processes and help us determine which sites or which parts of sites should be excavated and documented before they disappear entirely. I'll wrap up this presentation with a few final conclusions and main takeaways. The first being that photogrammetry and 3D modeling are cost-effective and efficient means of digitally preserving archaeological sites. The relatively fast process of 3D modeling allows archaeologists to create archives of site models and detect changes at sites over time and between field seasons. This allows us to assess the rate of climate change destruction at sites. 3D models can capture digitally an archaeological site before it entirely deteriorates due to erosion or permafrost thaw. And finally, photogrammetry and 3D modeling are important and useful methods with broad applications in archaeology, especially in Arctic archaeology. And that concludes my presentation. I hope you found it interesting, and I wish you all the best of luck with the end of the semester.